I think we'll kick off, everybody. Good afternoon and welcome to this first MHIQ lecture for 2021 and the first face-to-face grand round for the Gold Coast University Hospital. Fantastic. I'm Paul Scuffham, Director of the Menzies Health Institute, Queensland, and I have great pleasure in introducing Professor Nigel McMillan, the Director of Immunology and Infectious Diseases Program within our institute. And Nigel's got a wealth of experience in infectious diseases and immunology, and he's going to talk to you about COVID, what's been happening and what the landscape, where it is at the moment, and all sorts of things. So feel free to ask questions and hand over to you, Nigel. Welcome.
Thanks, Paul, and thanks everyone. Good afternoon to everyone in the audience and everyone online. You online won't be able to see me, but you should be able to see my slides, and you audience, unfortunately, get to see me. Now, I'm going to talk about COVID for the next sort of 45 minutes or so, 40 perhaps, and I want to leave a bit of time for questions at the end. Everyone always has lots of really interesting questions, and the way we'll run the questions is through the chat function. So I'll be reading the chat and answering questions as they come along. So if you have questions, please feel free to put them in the chat, and I'll try and get to all of them as we go along. But otherwise, speaking of the Gold Coast University Hospital is auspicious because clearly this was the hospital that had the first case in Queensland. Some very famous people with COVID in Queensland here at this hospital, and really in some ways this hospital's been leading the way in terms of dealing with it. Now, let's see if I can work out how to advance the slides. There we go. So we all know that in December 2019, there was this outbreak of a novel set of pneumonias in Wuhan in China. And you can see the Science magazine cover. And this was around 24 cases. And at this stage, it appeared to have come from a seafood market in China, although that doesn't appear to be the case now. But certainly a large number of those early cases were associated with that particular actually live animal market at that time. And this turned out to be a novel coronavirus, and we'd seen these viruses before. So the SARS outbreak of 2002-3 from Hong Kong was a close relation of this particular coronavirus. And of course, MERS, which is the Middle Eastern respiratory virus, which is still bubbling along happily, I guess, for the virus at least, in the Middle East, but at very low numbers. And so you can see on this phylogenetic tree where the circle is where the coronaviruses and the SARS-CoV-2 actually fit. And so this was a virus that is called coronavirus because of its unique shape. It has a sort of crown-like structure, and these crown-like structures are in fact the spike protein, which is famous because that's obviously the protein most of the vaccines are based on. So this is the outer coat protein of the virus. It's the thing that the immune system sees first in most. But otherwise, it's a pretty small, double RNA virus. So otherwise, fairly unremarkable in terms of its electron microscope structure, at least. Now, this is a slide I have to update every time I give a talk because the numbers change all the time. So this is data from 2 days ago, but I would probably could add on another 1 million or so deaths, cases, and another probably 50 or 60,000 deaths to this figure. But if you look at what the situation was back in the 24th of January, about 13 months ago now, you can see that we were having cases obviously in mainland China, and there were outbreaks through Spain and Italy, and some in the United States of America. And for all the bits of data I'm going to show you, I'll reference where I got it from, hopefully for all of those slides. Today, of course, the situation is that this virus is spread to every continent except Antarctica, and it's probably only a matter of time before it gets there, and that the burden of cases, essentially the darker the colour you see on this map on the right, the more the cases are. And if we delve deeper into that, you can see that looking at cumulative numbers of cases, you can see that the champion of all this is the United States. And, there's a lot of reasons for that we can go into, including a pretty anemic response and the fact that the whole virus got away from them pretty early on before public health measures were put in place. But followed up by, in terms of case numbers, since the first day that they reached 10,000, India, We have Brazil following up, and you can see the others, the UK as well. So overall, this particular virus is 110 million cases as of 2 days ago, and nearly 2.5 million deaths. If you look at the distribution of cases, about a quarter of all the world cases are in the United States, and sort of spread around, in the 10% mark to Brazil and Russia and India, etc., etc. So, but every country basically has it. Now, if we actually look at the sort of way this thing's panned out over time, now this is daily confirmed cases per million, and I've just included the United States, the United Kingdom and Germany here. Australia is there, but you won't notice it because it's just this flat line essentially, because in comparison to those other 3 countries, we've had very few cases. And we'll talk about the Australian situation in a minute. But you can see, for example, the United States has had at least 3 waves, probably 4, but one back in March early on, another in July, and then obviously from November on, there's been a large number of cases, although those case numbers are starting to come down. The United Kingdom also has had 3 waves, whereas Germany's probably had, to be fair, 2 waves as things have gone on. And of course, the success of every country is well documented. You read it in the media every day. I don't need to repeat all this to you in terms of their ability to control the virus. Now, how is this virus actually transmitted? Well, we know it's transmitted by people in close contact via particles that remain in the air as droplets. Now, this has become rather controversial recently because of the outbreak in the Holiday Inn in Melbourne, where the thought was that aerosols created by a nebulizer were responsible for the spread of this virus. My own personal opinion, if you wish to know, is that this just doesn't quite make sense to me. We know that nebulizers certainly spread whatever they're nebulizing around the place, but virus isn't in that nebulizer. But look, we'll wait and see as time goes on. There certainly seems to be divided opinions on this, and I'm sure you all have some expertise I don't have in this area. People pick it up, obviously, by touching infected surfaces, but we actually know the virus is in many, many other secretions and fluids and the like from the body. So it's in the stool, the blood, semen, it's in ocular secretions, and we really don't know the role of those in terms of spreading disease. It hasn't really been looked at, some of these, very closely at all. And interestingly, we know that animals get it. So cats, including big cats as well as domestic cats, so tigers and lions have got COVID-19. Ferrets and hamsters, of course, get it as well. Now, mice don't, and that's why when we do our work with COVID, we need a genetically modified mouse that expresses the receptor for the virus. And I'm not going to get much into any molecular virology in this talk at all, but that's the only way we can make it work in a laboratory situation. Or we work with ferrets, which tend to be very bitey, and so we don't have the facilities, at least at Griffith, to do that. In terms of the risk of transmission, we know that this varies by type and duration. So the longer that you're exposed to someone and the closer you are to them, the higher the likelihood of transmission. And load is clearly a factor. And we think that the outbreaks that we've seen recently from both Brisbane, Perth and Melbourne with the new strains is potentially a factor of load. Now, why do we talk about these particular new strains being higher load? Well, in the lab, if we grow them in the cells in the lab, they produce nearly twice as much virus per input. So they grow really well there. In terms of load in patients, I don't see a lot of data out there, but the thought is that the person infected with these variants are shedding a lot higher load of virus. And certainly it's spread quite well, and eventually those strains will dominate. And there'll be a new strain that comes along as well, because while the virus is replicating, we are getting new variants. The more it replicates, the more new variants we're going to get. Preventative measures, of course, mask, distancing, hand washing, we all know work quite well. And of course, the reason we have had such a minuscule flu season in Australia this year is probably a lot to do with these particular measures. Secondary infections are quite common in household contacts. And my computer's done something strange. There we go. This is also in healthcare settings where there's poor PPE or in closed settings. Now, cruise ships are a very popular topic with the media early on, obviously, because of the situation we had both in Japan and in Australia. And air conditioning has become very popular too. Now, interestingly enough, transmission in aeroplanes is really rare. It's actually not seen at the levels that you would expect if you were comparing, for example, something like TB, which spreads quite readily that way. But we don't see the spread of SARS-CoV-2 in aeroplanes. With cruise ships, we certainly do. But when you carefully look at the air conditioning systems, they're not spread via those air conditioning systems. The patterns don't match that. And that was quite a careful study that was done on the Japanese cruise ship. And obviously, social, family and work gatherings push this along. Now, we've had new variants, and as I said, the more cases we have, the higher the number of variants we'll see. So B1.1.7 is the UK variant. It's spreading now quite widely. We have it in Australia, at least in hotel quarantine. It seems to have increased transmissibility. We don't have an idea that it has increased severity, and it has slightly reduced vaccine efficiency and in vitro neutralisation. So we'll talk about the vaccines that Australia have got and their ability to tackle these strains later on. But this is sort of a more general comment. B1.351 is the South African strain. It's not quite as widely spread, probably just reflecting the travel from that country. It certainly has a potential increase for transmissibility. It is more moderate or more severe reduction in vaccine efficacy, so it's a bit more problematic. And certainly the monoclonal antibody neutralizations from companies like Regeneron, who sell this and have emergency use authorization for treating patients with mixtures of monoclonal antibodies, appear to have severely reduced efficacy against this particular strain. And the Brazil strain called P1 it's unknown at this time what that's like. We just don't have enough studies. Just further on spread, then, how easy it is to spread SARS-CoV-2. So this is a case I like to use that was early on in March 2020, and this was a choir practice. Now, there were some 61 individuals at this choir practice. Now, what you can see on the slide is the plan of how they were set out. The infected person happened to be right on the end at the back. Now, all those people in yellow got infected. They were singing, of course, their little hearts out in choir practice, and of course, this is a great way to spread respiratory viruses around. For singing concerts, when we have to approve them in the con, for example, and for my sins, I sit on a committee of the university to approve such activities. 4 metres is the distance we require from the audience, and so it's quite a long way. So it spreads incredibly rapidly, and that was just one session of singing over a few hours. And we've seen these sort of super spreader events at weddings in New South Wales, for example, and other activities like that. Of course, another thing I thought I'd never been doing in 2020 was estimating what the virus spread might be from orchestral instruments. So if you're playing the cello or double bass or the violin, you're fine. But if you're playing the flute, it turns out the flute is the most dangerous instrument in an orchestra. A nice straight tube to direct out virus straight out the end of it there, and it is also has been shown to go at least 4 metres. So yeah, if you have a child who plays the flute and they're not feeling very well, you might want to keep a bit further away from them, or not at the business end of that flute anyway. So in Australia, we've had 2 waves essentially. We've had 28,000 cases, 909 deaths. So we have been really fantastic in terms of our control. We've certainly learned a lot of lessons on the way, probably lessons that were learnt in 1918 with the Spanish flu that we probably forgot. And of course, we've learned more every day, particularly around hotel quarantine and quarantine in general. This is not an easy thing that we do, trying to keep an infectious respiratory virus at bay. Now, I think one thing Queensland does really well that other states don't seem to do is that we ship all our infected patients off to facilities like this, into infectious diseases wards with negatively pressured rooms and highly trained staff who, of course, are trained to deal with this particular situation as well as everyone else. And so I think this has been a hallmark of Queensland's response, which has been quite good. Other states tend to use medi-hotels, and certainly they have more highly trained staff than normal hotels, but those rooms really aren't set up, I think, properly for that particular purpose, as they're finding out. Now, the outbreak, I guess, in June, the second outbreak that happened in Melbourne and Victoria was around poor hotel quarantine control, and then essentially gatherings of family and friends and social gatherings that led to that second wave. So we know really what causes it. So why is this virus so difficult to control? Well, it's highly infectious, and everyone talks more about the new variants being even more highly infectious, but the original virus, even the original strain in Victoria, Vic1, is a really infectious virus. Of course, there's no pre-existing immunity, but really the problem is that people are viremic when they are pre-symptomatic and they are or asymptomatic. In fact, 40% of transmissions are from asymptomatic people. Now, here's some data on that from JAMA in January this year. In fact, this is now updating that 40% figure because that slide was old. And it shows that 59% of all infections result from asymptomatic transmission. Now, that's 35% of those of that is made up of people who are pre-symptomatic, so they will go on to get symptoms, but they are viremic before symptoms show up. And this, of course, is the hallmark that's so different from the original SARS virus, where people only spread the virus when they were actually sick. And so it was easy to control. We managed to isolate those sick people, and the virus didn't spread as well. That's why it disappeared. And 24% from individuals who never develop any symptoms. And this, of course, makes it difficult, of course, why we have things like surge monitoring, because there are people out there who don't even know they have this virus at all. Prevention, I don't need to go through all this. We know what we need to do. This is pretty clear. The public health measures have been an interesting and somewhat divisive at times set of restrictions. So travel restrictions are fairly clear. Stay-at-home orders, such as lockdowns, the limitation of public gatherings, closing schools and non-essential businesses. And then the idea of case identification, contact tracing and isolation quarantine for 14 days. Although if you're in the UK, that's 10 days, and I don't really understand the logic, although I must say I fail to understand the logic of many of the UK government's implementations of control, and I think the data would suggest they have done a pretty poor job of it. The reason for 14 days is this is an early study from the Annals of Internal Medicine in 2020, showing that basically the average incubation period is around 5 days for people, and that 97.5% of people will show symptoms by day 11.5 or be viremic. But you've got most people by 14 days, near to 100%. But there are rare cases of people who seem to have a slow infection, or perhaps it's a strong immune response, where they don't really become viremic until much later. So one case of 27 days, for example. But 14 days covers the vast majority of people. The disease itself, I watched Channel 9 News last night, I'm sorry. I'm sorry. They got two things wrong in their first two bulletins. First of all, that breastfeeding mothers shouldn't be vaccinated. Well, the government advises they're perfectly fine to be vaccinated and continue breastfeeding. And the second one was that there's an outbreak of RSV, and this reporter, by the way, was standing just outside this hospital and saying that the symptoms are so similar because you have a runny nose. And I'm sorry, you don't have a runny nose with COVID-19. It's one of the things that separates it, apparently, from normal common cold type symptoms. But anyway, or other viruses. So fever, cough, fatigue, anorexia. There are some interesting other symptoms. So this loss of smell or taste is interesting, as infection clearly goes into the olfactory area and nerves. And in fact, the virus certainly gets into the brain. And you can, in animal models, we can certainly see the virus replicating in the brain quite happily. Sore throat, congestion, etc. So there's a range of symptoms that are less. So as I say, many of you already know this, some of you don't, so I'm covering everything. Just thinking about the spectrum of diseases. So this is, once again, from JAMA in 2020, just looking at 44,000 cases in China. So the vast majority of people have mild to moderate disease courses. And then severe is about 14% and critical 5%. So the case fatality rate, at least as reported in this particular study, was 2.3%. So most people, of course, under the age of 65 will have an infection and they'll recover from that. Clinically, I guess the issue really is acute respiratory distress syndrome. And this is interesting in the sense that the virus replication has gone up and down, and then an inappropriate activation of the inflammatory response then kicks in later on to cause this particular issue. Kidney injury, there's hyperinflammation, there's cardiac injury, arrhythmias and cardiomyopathy. There's a hypercoagulation syndrome, which is problematic, and neurological disorders, which I think we're probably coming to terms with, particularly with long COVID. And then in children, this multi-system inflammatory syndrome. I'm not a clinician, so I'm not going to lecture you about clinical things, but the issue with the clinical response is that, and I'll just get my screen to actually come back, is that, the mild and moderate cases seem to have a well-regulated immune response that could be, it's either going to be well-regulated or dysregulated. And so what you see in people who have mild is they have a nice peak of interferon, they have a nice increase in bump in lymphocytes, their immune system controls it quite well, whereas the response in severe disease seems to be less muted. The virus certainly has found ways around the innate immune response, and there's differences in cytokine levels between them. And animal models probably aren't very adequate in this. And this is an IMPRESS autoimmunity review. So another thing that's probably becoming more evident now is autoantibodies. So this is from Nature. Rogue antibodies are driving severe COVID. So there's some evidence now that some autoantibodies could be key to understanding some of these worst case scenarios, or perhaps understanding long COVID, which is really the consequences, the long-term consequences of this disease. So this is from The Lancet, and this really talks about a 6-month follow-up of about 1,800 or 1,700 patients in China. And basically, more than half of them had fatigue and weakness 6 months later. 26% of them had sleeping issues. 23% of them had anxiety and depression. So we don't fully understand what's going on here. Certainly, virus infections can have long-term consequences, but I think really this is only something that time will tell us more about. Okay, what are the risk factors? So there are two things I really wanted to talk about here. Clearly, age is a risk factor. So on the bottom right here, you can see that when you actually look at, and I think this one is hospitalisation rate. Get my actual glasses on to read this. That would help, wouldn't it? Oh, it's death rate. The older you are, the higher the risk of death, and men more so than women. But clearly, over the age of 65, being a male, severe obesity, diabetes, obviously serious heart conditions like hypertension, etc., immunocompromised state. None of these are really a surprise, I suppose. Each of these, in a sense, are an inflammatory condition, I suppose, severe obesity, diabetes. So there's clearly those risk factors. And there's an interesting risk factor, too, around race, although there's probably societal reasons for some of this as well. So what you see here at the top left of this is fatality rates. And if you look at in the grey is the demographic, so that's the proportion of the population that particular group is, and then COVID-19 deaths. And so you can see that Asians, while they represent a larger portion of the demographic than their death rate, but Latinos, it's the opposite. And certainly for African Americans, that's the case, and that is over a number of different states. That's the publication down there that talks about that. Whereas for white people, or Caucasians, then this is, they have a reduced death rate compared to their demographic. Now, part of this, of course, in America, probably structural racism, crowded living conditions, multi-generational homes, and there's a lot of reasons, air pollution, perhaps in some areas, and poverty, particularly with the healthcare system America has set up. So it's kind of interesting. Testing, we have a number of different tests for COVID, obviously the gold test, and this happens here, of course, on this site. So lots of molecular tests, which essentially PCR tests is our gold standard. Antigen tests are now becoming more popular. and antibody tests. So the antigen tests are interesting in that these are these rapid lateral flow type devices that will give you a test result in 15 minutes or so. This is the test they're using on our healthcare our quarantine workers at the end of every shift. And then they get PCR tests once a week, as I understand it. This is just more details about each of those tests. The antibody test really only tells you if you have had the virus or in the throes of having the virus after about 7 days when antibodies start to become apparent. So probably not so useful. So gold standard PCR and antigen tests may be useful in different situations. So in fact, Brisbane has an interesting history or story in this, and that is Loom, who are based out at Richlands in Brisbane, have just signed a $300 million deal with the NIH and the American government to supply them with tests. In fact, they will build a factory in the United States to keep up with the supply they promised they would give, as well as keeping their facilities here. Curiously, nothing's much is happening in Australia with the Loom. I don't know quite why that may be. But this is something that the United States has seen as a very important part of their arsenal in terms of SARS-CoV-2 control. Now, in terms of treatment, remdesivir is an antiviral not developed for this particular virus, but is for other viruses, and it's approved now both in the United States and I believe here. Dexamethasone, which is really cheap, and we have a long history of this, particularly for the acute inflammatory syndromes, is just a steroid. Emergency use in various countries, so I'm not necessarily just talking about Australia here. Convalescent sera doesn't seem to work perhaps so well, difficult to get, but monoclonal antibodies have been certainly tried, certainly something that the president at the time got, the Regeneron monoclonal antibodies, but there are a number of products there and currently either with emergency use and undergoing testing in phase 3. Immune modulators like interferons, probably not going to be successful. If you get it in early enough, then interferon can have an effect, but obviously interferon goes way up. It's just really there to hold the virus at bay until adaptive immunity comes along. What we desperately need is direct antivirals. So we really don't have, remdesivir is not very good. It's a protease inhibitor, but it's not actually that great. We need direct antivirals, and this is something that Anthony Fauci was talking about at Keystone last week, and some of my slides have adapted from his. But we don't seem to have any good, and there's lots of research and there's lots of companies looking at new antivirals, and I'll talk about some of the research going on around here on that in a minute. In preclinical development, there's things like siRNAs and CRISPR, repurposing of old drugs, there's a lot of screening going on, immune modulators to control that inflammatory syndrome, and a wide range of anti-inflammatories are being tested. So there's lots and lots of activity, and there's an enormous amount of money that's being poured into this sort of preclinical development by the NIH and European, everywhere, even in Australia. And we ourselves are the recipient of an MRFF, a Medical Research Future Fund grant for our therapies. And I'll talk a little bit about there. And actually, I'll show you a result hot off the press. What doesn't work? Oh boy. This has been interesting, hasn't it? So despite what certain members of parliament might tell you, hydroxychloroquine is not effective, and the data and the evidence for that is quite well covered in this JAMA article if you want to go and look at it. I'm not going to get into it here, but it's clearly not effective. Ivermectin, we really don't have sufficient data yet at this time. And the reason ivermectin was quite popular was that it had quite promising in vitro results. Now, look, I'm a scientist and I know that in vitro results don't translate to in vivo efficacy, even in an animal, let alone in a human. So, and it had to be at quite high concentrations you couldn't clinically achieve. So the evidence base can be viewed at that particular website if you want to go and have a look, but really there's insufficient data to recommend it at this time. Vitamin B, D, and C, there's no convincing evidence for those. But I get asked all sorts of and I get unsolicited emails regularly on the way to cure COVID. And sometimes I politely reply and sometimes I don't. Now, vaccines, obviously, this has been an amazing story. To think that this virus has now been with us for a little over 14 months. We now have, well, more than 80 vaccines have either been tested, abandoned, but into humans in some sort of clinical trial phase. Now, this website is the New York Times Vaccine Tracker. It's a fantastic website. This is a few weeks old now, but honestly, look it up. You don't even have to have a subscription to the New York Times. They show this one for free. But there are 36 vaccines in phase 1, 25 and 2, etc., etc. 3 have been approved for full use. Now, this is American data, of course, and 4 vaccines have been abandoned, including the University of Queensland vaccine. The platform technologies behind most of these vaccines are interesting. So this mRNA vaccine, which is really just a blueprint to make the virus coat protein, the spike protein, is new technology, at least in terms of going into humans. It's been talked about and tested for many years, but it was always thought to be too expensive. Manufacturing was an issue, but that's all really been solved by this pandemic in a sense. And I think, in fact, if I was to use my crystal ball, I think RNA as a medicine is going to become incredibly popular and important in the next 20 years. So the Moderna and the BioNTech Pfizer vaccine is based on this. It has authorization in Australia, and its efficacy, well, this goes up and down on the trials, but generally high 90s. AstraZeneca's is an adenovirus, so this is a viral vector. So they put in the instructions for the coat protein in the genetics of this particular virus. It's a harmless virus. Actually, for AstraZeneca, it's a chimpanzee adenovirus that is doesn't normally seen in humans. And the reason for that is that we have all seen many adenoviruses in our life, and so pre-existing immunity may blunt the response if we use a human adenovirus. Efficacy seems to be a little bit less, but these are all 100% effective at preventing death. And there was one case of serious illness in the AstraZeneca trial in their 44,000 patients. So I kind of say it's almost 100%. It's 99.9997 or something effective at preventing serious illness, which is, what you want your vaccines to do. And then the Novavax is the one that Australia have also bought. This is a protein-based or recombinant protein, traditional vaccine technology, 89% effective. That just came out a couple of weeks ago. I just wanted to show you this one. Now, we don't have the Moderna vaccine, but this is just the timeline. And it re-emphasises the amazing progress that was made. So on January the 10th, the Chinese released the sequence of that virus, right? So in 5 days later, right, they had started planning the evaluation that was going on. And they, in fact, got an mRNA made. And phase 1 trials began in March, 65 days after the sequence was released. Phase 2 started 139, phase 3, 198, because they were overlapping these things. And emergency use authorization happened in 325 days. Now, this is great and fantastic, but what we have realized is this has caused a lot of angst in the public about, was this rushed? Is it safe? I'll talk about that later. This is from Bloomberg. But this is just a nice look at the Australian vaccines. So Pfizer, all the data is here. It's been tested on 44,000 people, minus 70, we know, at 95% effective. And the red is the trials. And then yellow is it being submitted to the regulator and approvals in green. So you can see Novavax in the throes of getting data to the regulator, the TGA. And AstraZeneca now obviously have been approved. So last week. So this is all good news. We've got 3 great vaccines that seem to be quite effective. And if we just look at this just came out about a month ago now, and this is like the cumulative incidence curves for the first COVID occurrence using, but in this case, the Pfizer and Moderna vaccines. And this just shows over time the number of cases of COVID-19 and placebo versus vaccine. And you can see clearly that it's quite effective. So those people who will tell you the vaccines don't actually make you immune, and that's another one I get quite interesting often, that this doesn't exist, are clearly wrong. Novavax, so this is just from their press release, not actual data that's published, but so I warn you, it's a press release from the company, so it's conflicted. But they report 89% effectiveness. And that's where more than half the cases were the new UK variant. So that's really good news. The South African, they had an arm there, and it was only about 50% effective, and most of those were the South African variant. So that's just reduced effectiveness. And clearly, I think all the vaccine companies are going to have to rejig their next round of vaccines to include the variants here. If we're getting to that 50% mark, that's problematic. So the unknowns for the vaccines is how long will immunity last? And I can't tell you because, well, the first jab went into someone 7 months ago, essentially, in March. So almost, well, I suppose 11 months ago now. So at least as long as that. Will we need boosters? We know that natural infection with SARS or MERS gives 3 years of antibodies that are neutralizing. So whereas normal coronaviruses, the 4 strains that cause the common cold in us, wane after 12 months. So is it one of those two? I suspect personally it'll be 3 years, and we may need to boost and with new variants anyway at that time. In the long run, I suspect it'll be a 5-year booster, but we'll wait and see what the data says. Will we get cross protection of variants? Clearly, that is reduced. Efficacy is reduced with particularly the South African variant, and pregnant women and children. So trials are now starting on children with AstraZeneca. There's no particular reason we would think pregnant women can't. We obviously vaccinate pregnant women already for influenza and rubella, but we just don't have the data. So that's caused a bit of angst as well. The best COVID vaccine's probably not yet made, and there's probably new versions, so new live attenuated vaccines, multi-version mRNA vaccines, and maybe even nanopatched vaccines using technology from Brisbane. Who knows? This is a survey, although I noticed one came out yesterday for Australia, but this is an American survey from Kaiser, who just surveyed people to see what their concerns were. And you can see the majority, about 70% of people are concerned about the long-term effects of the vaccine are unknown. I often get asked will these mRNA vaccines affect my genes? Will I get in and change my DNA? Now, mRNAs can't get into your nucleus, but it's a legitimate concern people have. So we don't know what the long-term effects are because we haven't vaccinated people long-term. We wouldn't expect anything to be an issue. And in fact, this has made a lot of people say, I'll get the vaccine, but I'm going to wait to the last moment to get it, sort of thing. Will I get side effects? Well, we know from the trials that the side effects of vaccination are pretty routine with most vaccines. And I'll have some data there, I think, on that in a minute. Are they safe? Are they effective, etc.? So the usual sorts of concerns. We need to get to herd immunity to get, I guess, somewhat back to normal. So this is this indirect protection against disease when we have either vaccination or previous infection to a level of, well, we think 70%, maybe 85%, we don't know. We know for measles, it has to be 95% because measles is incredibly infectious. So we don't really know, but I think 70 is probably where most people are sort of pitching it. The challenges are, of course, vaccine hesitancy, the unknown role of vaccines preventing transmission. So data out of Israel would suggest the Pfizer vaccine does prevent transmission, and the AstraZeneca data suggests it prevents transmission in about 2/3 of cases, or reduces it by 2/3, which is good. What's the new variant's going to do, and will the immunity last? Now, I wanted to just in terms of side effects, so we know that about 11 in a million people will get an allergic reaction against the Pfizer vaccine. That's pretty good. Consider that 500 in a million are allergic to penicillin. So we're kind of happy with that. Although, interestingly, 10% of Americans claim they're allergic to penicillin, and that can't possibly be true. Anyway, people are funny. So what are we doing at Griffith? So there's a whole list of projects here that are going on. I'll talk about a couple of them. We have funding in my own laboratory with Professor Kevin Morris, who's sitting in the audience here, around lipid nanoparticles to turn off viral genes. We have some other collaborations with companies around exosomes. There is Professor Suresh Mahalingan has researched with Indian immunologicals for a vaccine, a live attenuated vaccine, which has been de-optimized so that it doesn't grow as well. And the advantage of that vaccine is, of course, you make a reaction against all the viral proteins doesn't cause disease, but you get a much broader. So this may take care of some of those issues around variants, which only rely on changes in one protein to escape vaccines. So that's quite promising. And there's industry partners for anti-inflammatory drugs. There's a lot of drug screening going on at the Glycomics Institute, and I'll present some of that. Professor Paul Scuffham has certainly published on the economic impact of COVID-19, and we're looking at mental health issues around social services closures in older people. And that's Wendy and Katiana. So we this is the only bit of research I'll show you from us. We use nanoparticles we developed to treat Hendra many years ago to target COVID-19. And in this experiment, we took some mice and we injected them with our treatment at day -1 and day 2. We infected with virus at day 0. And we followed them out to day 6. Now, so this is quite a limited experiment. We would normally, I think clinically, you'd treat every day anyway. You can see that we reduced the amount of virus that's in the lung by about 20-fold. Survival is, for those treated, is 100% versus those with just the virus or dying and or being euthanized ethically. And so this is really promising data that we've got here. And this is my team here, along with Professor Kevin Morris, as I said. So Adi Idris, Arun, who's in the audience, Druba, Gabby, these guys work 7 days a week in really horrible PC3 conditions with lots of suits and space suits and sweating, and they're not allowed out of there for 3 hours. And it's a heroic effort. So I thank them very much for the great work they're doing. They're really tremendous. The Institute for Glycomics is looking at repurposing drugs. So they use screening to look for whether they can repurpose drugs that have already been in clinical trial in humans. And this is obviously a great way to get things in there really quickly. This is already in press in MBio if you want to go and have a look for it. That looks really good. So that was over 3,000 existing drugs. They're also looking for structural guided guidance to make new drugs. So they have NMRs over there. They can look at the structure of the protein and make drugs that will fit like a lock and key. That might be quite useful. So sort of designer drugs in that sense. And also vaccine development. So they are looking for conserved epitopes so we can avoid those variant issues that we actually get. Okay, so I promised you I'd talk for 45 minutes. I pretty much have. I've got a couple more slides left. So what's the future look like? So I think travel will return to normal between vaccinated populations. So if we get herd immunity in Australia, and even better if it stops transmission, the virus will eventually stop circulating. Variant formation will reduce because the virus can't replicate. And so if we have 2 countries like that, then there's no particular reason travel can't return to normal. But then again, this is politicians we're talking about who make these decisions. So I can't speak for them, and sometimes they have interesting agendas. But what about lower middle income countries? You know, what about our Pacific Island friends, Papua New Guinea, our close neighbours? What are we doing to take care of them? Because this is a problem that has to be solved everywhere. You know, ultimately, you've seen the scramble of first world countries grabbing vaccines and the like, and there's very little left over. And so that's something I think over time will equalise out through Gavi and COVAX through the WHO. But you know, this is a bit of a problem. So that, okay, we can travel to the UK, but you know, if we have international students who want to come from Africa, how do we get them here? You know, with colleagues that want to visit us, how do we do that? It's going to be interesting. If we get herd immunity, but it probably doesn't prevent transmission, which is likely, I think COVID-19 becomes flu-like. You know, remember 2,000 people in Australia die every year from flu, and that's normal. That's what happens. In fact, 3,000 more die of pneumonia. It's probably flu. It's just not reported that way. It's not tested. So, and we accept this. So ultimately, as long as, you know, once the vaccines are in our aged and vulnerable, deaths will disappear, hopefully, to a large degree. But there will be people for whom the vaccine can't work or doesn't work, whose immunity is waning as they get very old, and that's what flu does. Luckily, unlike flu, COVID seems to not affect the young at all. Hopefully we'll stop watching every case. At the moment it is, oh my God, there's 1 new case. Imagine if that was flu. It's amazing. And this will be an interesting mental switch off for everyone. And I'm not sure how we're going to do it. It's a unique situation, but we're going to have to stop the media reporting on every little case, because once we've got herd immunity, it won't matter so much. The public health measures might become more flu-like, but you know, the government have fallen in love with some of these great public health measures, and even though they're emergency authorisations for the chief health officers to do these things, will they give back that power? I don't know. It'll be interesting. That's more of a societal issue, perhaps. And will we get high enough herd immunity anyway to stop virus circulation? I think that's really the thing that will allow us to move forward in this. And so we shall wait and see. So thank you very much. I'm going to stop sharing the screen now, and I will move on to the chat. And if you have questions there, I will try and answer them. Let's see, where is the chat? Okay, goodness me, there's lots of things here. If there are any questions from the audience too, I'll repeat them and ask them.
I'll kick off, Nigel. Thank you for that. It's very interesting. I've noticed the antiviral research going on, and back when they developed the Glycomics Institute and their colleagues in South Australia developed Valenza for influenza and Tamiflu, there was a lot of concern about there's going to be a bottomless pit for money to spend on antivirals, because everybody would want an antiviral all the time to prevent them getting the flu rather than taking when they do get the flu. They were looking at using the antivirals as a preventative measure. So you know, during flu season, the whole population would start taking antivirals to get vaccinated. So it cost a hell of a lot more, billions. So that was a major concern to the governments.
Yeah, I think antivirals are expensive, and you really want to hold them back for those who are sick, and you want to make sure they don't move on to that inflammatory syndrome. Vaccination is our most effective public health measure. So the question was antivirals versus vaccines, and how widely available would we make antivirals? Do we want them over the counter, etc.? And that's obviously a very expensive undertaking to do. So yeah, vaccine's going to be our most effective public health measure. Okay, just a minute. Let me see if I can. So there's a question here from Mahinda. Why are we excluding pregnant women, whereas US CDC guidelines include them? Right, so you're right. So there's in fact been a bit of a dichotomy here. So the UK have said no to pregnant women at this time, not because they think there will be an issue, but because they just don't have data. The US CDC have said maybe. It's up to each individual case. So, for example, if you're an infectious disease physician or nurse or someone who deals directly with those patients, or a frontline healthcare worker or a quarantine worker, and you're pregnant, you should discuss that with your clinician, is what the Americans are saying, and make an informed choice. And it's up to you if you would like to get vaccinated, and you can if you wish to. So that's what they've said. The Australian government have said at this stage that they've taken the UK line, and that is we don't have data. We don't anticipate there should be any issues, but we just don't have the data yet. Now, interestingly enough, during the trials, women fell pregnant accidentally, or they weren't meant to, of course. They signed on to the trial with the idea that they wouldn't or shouldn't, but things happen. And in fact, there were 23 miscarriages on that trial, and 11 of them were in the vaccine group, and the 12 of them were in the placebo group. So there was obviously no relationship to vaccination status in that case. So yeah, I think the data is not there yet. So that's what the situation is, and whether the TGA changes their mind or not, I think they won't until they've finished a trial on it. Okay, are there any other questions? I'm not seeing any others. Diane Moses tells me there are 36 cases reported at a base in Antarctica. Well, you know, I wasn't aware of that. So there you go, we've covered the world. There's so much media on this, I haven't really seen it. Okay, well, if there are no other questions you want to type up in the thing, then thanks very much for joining us for Grand Rounds. And if you want to contact me, you'll find me in the Griffith email list, or just Google me and you'll probably find a contact detail, and I'm happy to chat with anyone. Thanks very much.
Thank you very much, Nigel. Pleasure having you.
weird. Look at this window. I don't